Earth, our home, a vibrant blue sphere teeming with diverse life. It holds a profound secret, an invisible, life-sustaining guardian. A vast magnetic bubble surrounds us. This is Earth's magnetic field. It diligently shields us all. Where does it originate? This powerful unseen force, deep within our precious planet, lies a churning molten heart, a core of liquid iron alloy, constantly in turbulent motion. This movement creates strong electricity. Electricity in turn generates magnetism. This is the Geodynamo, a natural engine at Earth's core. Picture a colossal bar magnet, thrust deep through our Earth, roughly aligned with its spin axis. But this magnet is not fixed, it subtly shifts, it often wanders, it even weakens and strengthens over time, protecting us silently, ceaselessly. It repels the harmful solar wind. Life as we know it thrives beneath its watch. This magnetic field is not constant. It has a truly dramatic history. It flips. It completely reverses polarity. Magnetic north becomes magnetic south. Magnetic south becomes magnetic north. This is a geomagnetic reversal, a profound but natural planetary change. These events are recorded in stone. Scientists discovered this amazing fact by meticulously studying ancient rocks, volcanic rocks primarily, basalts, as hot lava cools and solidifies. Magnetic minerals within it align, like countless tiny compass needles. They faithfully lock in the field's direction, preserving a snapshot of that ancient field, a magnetic fossil if you will. This process is called thermo-remnant magnetization. These rock records tell a long story. Reversals are not exceptionally rare events. They are a normal part of Earth's behavior, happening somewhat irregularly through eons, many times in our planet's long life. The last major reversal documented, it is called the Brunhes-Matuyama reversal. This occurred about 780,000 years ago. Our distant human ancestors were around then. The Earth simply kept spinning on its axis. Life in its myriad forms continued. So what truly happens during a flip? Does magnetic north suddenly become south? The answer is a definitive no. It is a very gradual, drawn-out process. A slow, meandering, complex dance of the magnetic poles across Earth's surface. Not a dramatic, instantaneous switch. Think of it taking many centuries, or quite possibly even millennia. Thousands of years from start to finish. The main dipole magnetic field weakens, it becomes significantly more complex. Multiple north and south poles might appear, scattered erratically across the globe. The field loses its simple structure. This transition is a messy affair, but not a destructive one necessarily. The magnetic poles themselves wander. They drift far away from geographic poles. The overall field strength greatly diminishes, perhaps down to only 10% of its usual power. This is the main transition period, a time of profound magnetic complexity. The shield is weaker, but not gone. Our atmosphere still offers protection. Then, slowly, the field begins to reorganize itself. Earth settles into its new magnetic alignment. Today in the year 2025, we are observing our magnetic field with truly incredible, unprecedented precision. Satellites like ESA's Swarm mission monitor it constantly from orbit. And what do these instruments see? The field is observably weakening, slowly but quite measurably. This is a current scientific observation. Over the last 200 years or so, the overall strength has indeed decreased, by about 9%, some studies suggest. Is this a definitive sign? A sure prelude to a new reversal? Perhaps, or perhaps it is not. The field fluctuates naturally, strengthening and weakening over time. This could be part of that cycle. We must continue to observe. This observed weakening is not uniform, not across the entire globe equally. Some areas weaken faster than others. Other regions change much less. The magnetic North Pole is also on the move, drifting faster than it did before, relocating from Arctic Canada towards Siberia. This rapid polar wander is notable, but it is considered normal behavior. We are simply observing a moment. Science requires patience and continued study. Understanding is our best tool. Section 5, the curious case of the South Atlantic Anomaly. There's this particularly peculiar region you see located over the vast South Atlantic Ocean. It extends over parts of South America and even Southern Africa. Scientists know it as the South Atlantic Anomaly, or SAA for short. Here, Earth's magnetic field is notably weaker, significantly weaker than elsewhere on the globe. This is a well-documented phenomenon, like a dent in our magnetic armor, if you will. It's a place of intense scientific interest. Now, this isn't a brand new discovery, but it is certainly growing in extent, expanding westward in size over decades. And the area of lowest intensity is also deepening, becoming more pronounced. This region presents known challenges for satellites and spacecraft passing through it. They're more exposed to charged particles, which can lead to potential electronic glitches. Astronauts, well, they also receive higher radiation doses here. The SAA might be a surface expression of unusual processes deep within the core. More research is needed to be certain. It reminds us that the Earth's field is not a simple, perfect dipole, but a messy, dynamic, wonderful thing. Section 6. Life Finds a Way. Past Reversals and Earth's Story. What about life on Earth? During numerous past geomagnetic reversals, did widespread mass extinctions occur? The geological and fossil record speaks, and it tells a rather surprising story. There is no clear evidence of widespread synchronous biological catastrophes linked directly to magnetic field flips. Life, it seems, is remarkably resilient. Life has endured many reversals, countless times over hundreds of millions of years. Organisms that possess magnetoreception, the ability to sense magnetic fields like some birds, sea turtles and bacteria, they might have been temporarily confused. Their internal compasses perhaps disrupted for a period during the transition. Navigation might have been challenging, but not insurmountably so, it appears. But evolution is a powerful force. Life adapts to changing conditions. The Earth's atmosphere also offers protection. Even with a much weaker magnetic field, it still shields us effectively from the worst of harmful space radiation. It acts as a crucial secondary defense. This atmospheric shield is very important. What about climate changes during reversals? The evidence here is currently debated. Some scientific studies do suggest possible links, others find no significant correlation. The Earth's global climate system is complex. More research continues to explore this. Section 7. Navigating a flipped world, our technological age. But we live in a different world now, a modern, highly technological world. Extremely dependent on delicate electronics, on global satellite networks, on vast interconnected power grids. A magnetic field reversal occurring today would undoubtedly present unique challenges for our modern, globalized civilization. Challenges our ancestors never faced. We are a wired, connected species. Satellites would certainly be more vulnerable to damaging solar flares and cosmic rays, especially during the weakened field phase. This could disrupt global positioning systems, affect vital communications infrastructure, and compromise weather forecasting abilities. We rely heavily on these space-based systems every single day, often without realizing. Our digital lives depend on them. Power grids on the ground too could be adversely affected by these changes. Increased charged particle bombardment could induce powerful geomagnetically induced currents in long electrical transmission lines, potentially overloading systems, causing blackouts. Protecting our critical infrastructure would therefore become a top priority. Humans are remarkably adaptable creatures. We would find ways to navigate as we always have throughout history. Section 8. Adapting to change, biological and environmental shifts. What about us, modern humans, and other complex life forms on Earth? Would increased radiation at ground level become a major health hazard? It would likely rise, yes, but probably not to acutely dangerous levels. Our thick atmosphere is a robust shield, a very good one, constantly at work. It absorbs most harmful radiation. The vital ozone layer in our stratosphere, it protects all life from harmful UV radiation. It could be slightly temporarily affected by complex changes in atmospheric chemistry induced by more energetic particles penetrating. But it would not be catastrophically depleted, leading to widespread immediate harm. Animals that actively use the magnetic field for their long-distance navigation, many migratory birds, for example, sea turtles returning to nesting beaches, whales traversing vast oceans, they might indeed face new difficulties. They might get lost more easily or take less efficient routes, but species have survived this before. The key is the extended timescale. These profound changes happen very slowly over many human generations, allowing complex lifetime to adjust. Section 9. Don't panic, prepare debunking myths, embracing science. So, should we collectively panic? Lose sleep over an impending flip? Absolutely not. That is not helpful. Fear often comes from misunderstanding, from misleading, sensationalized headlines. The actual science tells a different story, a story of a natural planetary process, a fascinating, ultimately manageable one. Knowledge dispels fear effectively. We must trust the scientific method. Myths and misconceptions unfortunately abound, that a magnetic flip means instant doom, that our planet's gravity will reverse. gravity is linked to mass, not magnetism, that continents will shift wildly, or that Earth will stop spinning. These are pure science fiction tropes, not grounded in scientific fact at all. The Earth's core generates its magnetism. It does not control these other phenomena. Instead of widespread panic, we need preparation. A calm, rational, scientific approach. Understanding the phenomenon is the first step. Investing in continued research is crucial. Developing more resilient modern technologies, shielding our vital satellites much better, hardening and protecting our power grids.